Hello, my name is Václav Petráš. I usually go by Vašek. My co-authors here, Corey White and Randy Hale, are here with us. And I will talk about navigating the geospatial open source software landscape. I'm not sure how much time should I spend with motivation for why would we even be using open source. Maybe can you raise hand if you used some open source geospatial or not? Okay. So you know that open source is used more and more. There is plenty of reasons. You can find many of these lists online. Now at the time when even Microsoft is a big open source player, then I don't know if we should even be talking about that much. In science, though, where I'm coming from, we are catching up, and there is really no question whether or not we should be using open source. We are just not doing it, although it's really necessary for things to be published fully. And then, without any research to back up, I'm just putting forward my observation that people who are using open source software are usually happier users of that software. Perhaps it's because they get more attached to it, or they actually feel that there are real people behind it, and there is a real community which is doing it very often to help themselves and to help others. So to talk about first about the terminology. So we have all these terms like free, libre, open source, and for the purpose of this talk, let's say that these all are very similar, although I will get into some more detail quickly. But there are some things which are very different from these concepts. One obvious one is proprietary software, often referred to in a wrong way as commercial software. Then we have free software and shareware. We have also a freemium model, which is usually a subscription model in clouds, where you get something for free, but then you have to pay for some more advanced features. And then there is also this thing called Open API. Well, Open API, there is actually a couple of things called Open API, but very often Open API is used for software or a service which has API which is public and publicly available to subscribers or paying users. That doesn't have to do anything with the word open as it is used in open source software. So these terms, libre, free and open source, they all have their own definitions, but if I should summarize it, there is this divide open source free software, where some argue that open really doesn't capture the needs of users for freedoms, so they want to use the term free software. And then of course, there is this problem with the word free, that it is often misunderstood to mean free of charge, as opposed to freedom. So some people suggested to use the term FLOSS, free, libre, and open source. One advantage, they say, it is actually a word, so we can pronounce it. But the other part is that we have there specifically the free, but on top of that we have also there the word libre, which emphasizes that it is not about being gratis, but it's about being libre. In other languages, as you can see with gratis and libre, we don't have the problem as in English with the word free. Very often these are quite distinguishable. In the geospatial community, though, we are quite used to use FOSS to mean free and open source, or free and open source for geospatial, where free would refer to users' freedoms and open would refer to the open source development model. And FOSS4G is then the name of the free and open source Geospatial conference. And as I said at the beginning, all these terms, they have their own definitions, and people or organizations which are defining them. One of these is Open Source Initiative. Another group which is defining these is Free Software Foundation, which created a GNU operating system with this cute logo, which is basically what we often refer to as Linux, and there is the whole discussion about what's that. But it's not really that important, as that at this point as the part that they define freedoms users should have, and based on that they are defining software licenses and definitions of these particular terms. So they say, as a user, you should have a freedom to use software for any purpose. You should be able to change the software to suit your needs. If you decide to do so, you can share the software with other people. Well, that's good if you want to share it with your colleague, with maybe colleague who is not part of your institution but outside of your institution. You can still share it with them, and you can share the changes into the software you made. These are maybe a little philosophical, but they actually have impacts in how the licenses look like. And then, of course, as you can see from the freedoms themselves, on how you are using the software. At the beginning, I touched at proprietary versus commercial, that these are often put together, but there is no reason FOSS software can't be used commercially as well. It can be, so free software or open source software can be commercial, but it can't be proprietary. That's the open part of FOSS software. It can be even used based on the specific licenses, can be used as part of a closed platform, closed in many different ways, let's say. And as you probably know, we have a lot of examples of tools which are open source, and quite successful. I try to list the non-geospatial ones. Since we are in North Carolina, you may have heard about Red Hat, which is now IBM Red Hat, I guess. Then Android, if you look at your Android device, there is in settings, there is a long list of open source licenses. And the same thing would actually apply to your iPhone as well. Then there is a Chrome browser, which has open source core. And quite recently, Microsoft actually switched in their Edge browser to the same open source core, which is called Chromium. Then there is, of course, Firefox, Moodle, and also Python and R, which everybody takes for granted that they are just there, but the reason why they are just there for everybody to use is that they are open source. And as I already alluded to, we have all these different companies, including Microsoft, using open source. So I don't know why I'm even talking about motivation for open source anymore. With the freedoms, which I listed before, that of course, that's the philosophical level, and then we have the licenses. And we have different types of licenses. I will talk about division into copyleft and permissive licenses. There are the copyleft licenses. A big example is GNU GPL, which doesn't allow combining the software tightly with with proprietary software. Examples of this are Linux, R, Grass, or QGIS, and you see that maybe in case of Linux you can run proprietary software on Linux, so you can combine it on a user level, but these apply more for the development level. Then there are permissive licenses like BSD or MIT license, And in this case, developers have additional freedom to actually modify the code and combine it or have it as proprietary as long as they keep the license in the source code. But that takes away some freedoms from the users because they are no longer able to use these changes. Example of this is, for example, is GDAL, which is open source. It's used in QGIS, GraphJS, but it's also used in ArcGIS, but you don't get ArcGIS source code. But for us as users, what are the important parts about licenses is actually open source licenses is not that much, because all these freedoms which I listed are usually inherent part of the license, and we don't have to worry about all these details in the license which are actually usually applying only to developers who are modifying the software. And to help you with understanding these licenses, there is a couple of different organizations like the Open Source Initiative or the Free Software Foundation, which categorize and describe the individual licenses. And talking about understanding the licenses, which is a thing which everybody should be doing also for the proprietary software or the services, you will all have the experience of checking the I agree to the terms and conditions. Okay, and maybe you read it, maybe not. They are very long, right? So in open source, that's different. There is just a couple of licenses. You just have to understand small part of these licenses, and that's all what you have to do as a user. So that's another advantage. You actually don't have to lie every day that you agreed to the terms and conditions. You actually know about them. You can even read the licenses, which is what I did for most of the software I have installed on my computer, because that actually means just reading one license, basically. To talk about the actual software, I will use GraphJS as an example. So software, we think about it as maybe something like this, some desktop interface, but in open source, the big part of it is the actual source code, but it is not the only part. Source code is usually available online. You don't have to read it if you don't want, but you can do it, and people sometimes do that and then report back to the developers that there are some suspicious things in the source code. You can see what changes are being made to the source code. The change is usually referred to as commit or change set. You can see author of the change, and you can see some description and everything what changed in the source code. And this brings us to the question, who can actually change the source code? Can it be anybody, like on Wikipedia, or everybody who is registered, like on OpenStreetMap? That's not really the case. What's the case is that for open source software projects, what you have to do is you have to get granted access to be able to modify the main source code of the software. That, of course, doesn't modify the software of the users once they install it, but it it's modification of the software in the central repository. And although this is limited, everybody can see the changes, as I just said. Everybody can discuss the changes. And everybody can get this source code and make changes in their local copy. And they can submit the changes for approval later if they decide to do so. In this process of submitting the changes to the main repository, we have usually some review done in different ways. Here is an example of that somebody did a review of code which I committed to GraphJS, and I tried to fix some problem with Python scripts on Windows. And this other developer, he actually didn't like how I changed that. Not that he didn't like it, but he didn't had good reasons not to consider this as a good change. And he actually reverted my change and suggested that we have to find a better solution. So these things are happening. People are actually reviewing and checking the code if it is correct. The standard way how to report issues in open source is open a ticket. Usually every project will lead you to some ticketing or bug reporting system. And of course, on one side you are thinking that the developers don't want you to find all these bugs, right? But on the other hand, they are at the end happy that somebody found a bug, because only when you find the bug, they can actually fix it. Another concept is feature request, where you are requesting a new feature to be added to open source, and the word request sounds like you are commanding the developers to do that, and you may think that you don't want to request the feature, but that's just a technical term how we call asking for a new feature. And if you really want to request the feature, then well, you can of course pay some developer to do that. And all these things, changes to the code and changes to the in the ticketing system are tracked in history, so that's something you can review. So to get to actual software, there is a lot of different software packages. How do you choose which one to use? Well, my question would be, how did you choose what you are currently using? Maybe you can just use the open source software your friend is using, if that was good enough a criterion to use the current software. And you can always switch, because you don't have to buy a new license, right? You can build whole software stack for your everyday use from open source, and that has a lot of advantages, like that you can migrate between different operating systems. You can plug in different open source packages because they are using standards, so they can actually communicate with each other, and you can install it to as many computers as you want. You can install it on your computer at home, you can install it in your work, and you can install it to all your colleagues. And then of course, if you want to use cloud and move to cloud, all this software can just scale there. One way how to decide which software is better is looking into development statistics, but that's probably something you don't want to do. So there are organizations like OSGeo, OpenStreetMap, Location Tech, or the conferences where people are talking about which software is better for what, and what is the best software for a particular task. You can get support from the community, but you can also get commercial support. The shameless plug there would be that NC State, where I'm from, the Center for Geospatial Analytics, we can provide you support, and my colleague over there from North River Geographic Systems, can provide you support as well. And that's all from me. All the links are here. The slides are online as well. And if you go to our list of classes, it's part of one class, and you can talk to me at NC State booth, which is down in the exhibit hall, or you can see me at the poster session. Thank you.